A distant object in our solar system could show how planets form, scientists reveal. More than a year after NASA's New Horizons mission closely flew by a small, distant Kuiper Belt object, researchers have been able to sift through the data and learn intriguing new details about this fossil from the formation of the solar system. Located 4 billion miles beyond Pluto, Arrokoth is the most distant object ever visited by a spacecraft. Previous studies about Arrokoth were based on a small amount of data sent back by the spacecraft, but the new details were provided by more than 10 times as much data. The data enabled researchers to get a more complete picture of the object and determine more about its origin, formation, geology, composition, color and temperature. And one of the most intriguing discoveries about Arrokoth is that it's covered in methanol ice and unidentified complex organic molecules, according to the researchers. If the name sounds unfamiliar, it's because the object was renamed in November. Previously, it was known as Ultima Thule, which became controversial after the name was linked to Nazism. Arrokoth is a Native American term that means sky in the Powhatan and Algonquian language, according to NASA. New findings about Arrokoth were presented Thursday at a press conference during the annual meeting of the American Association for the Advancement of Science. 3 studies were also published in the journal Science. Arrokoth is unlike other small bodies visited by spacecraft, the researchers said in one of the studies. Studying Arrokoth can shed light on how the building blocks of planets, called planetesimals, formed in our solar system. Arrokoth is largely unchanged after billions of years and acts as a primordial time capsule. The Kuiper Belt, a region of our solar system beyond the orbit of Neptune, is home to these old, cold objects, as well as comets, asteroids and other icy bodies. It's known as the third zone of the solar system. In one study, researchers were able to use data from New Horizons to simulate the formation of the object, which resembles a peanut or a snowman, depending on how you look at it. It's made of 2 lobes that gently came together after forming independently. Just as fossils tell us how species evolved on Earth, planetesimals tell us how planets formed in space, said William McKinnon, a New Horizons co-investigator. Arrokoth looks the way it does not because it formed through violent collisions, but in more of an intricate dance, in which its component objects slowly orbited each other before coming together. And while the 2 lobes have been referred to as pancakes because they appeared flat in some of the first returned images, another new study suggests that they are actually much larger in volume. Arrokoth's smooth surface is another indicator that the object is largely unchanged even after billions of years. It has a light scattering of small craters, likely caused by small, rapid collisions with other objects. The largest and most well-understood crater, dubbed Maryland, is 4.3 miles across. The others are much smaller. Arrokoth itself is about the size of Seattle. Multiple processes, including impacts, have reworked the surfaces of both lobes after their formation, producing the fissures and small dark hills, the researchers wrote in one of the studies. The third study took a closer look at Arrokoth's unique appearance. It's incredibly cold and the surface is covered in methanol ice. The object's signature red color is likely due to organic molecules also detected on the surface, although their exact composition remains unidentified. It's known as ultra-rare matter, a hallmark of Kuiper Belt objects because it's only thermodynamically stable in this icy region far from the sun. Methanol could be on the surface of Arrokoth as a result of several possibilities, including a mixture of water and methane ice that was exposed to radiation via the sun's cosmic rays. Water itself has not been detected on the surface of the object. The researchers believe Arrokoth is about 4 billion years old. And all 3 studies provide evidence that the object was formed in a collapsing particle cloud in the local solar nebula, the cloud of gas and dust from which our sun and planets formed. Its uniform color, smooth surface and how the lobes came together help piece together a picture of how the planetesimal came to be. As a cloud of particles collapsed, the individual particles condensed to form the 2 lobes that eventually came together. The gentle bonding of the 2 lobes happened at about 7 miles per hour, said McKinnon. This helps solve a debate over how planetesimals formed, both in the Kuiper Belt and across our solar system, said Alan Stern, principal investigator for New Horizons. He calls this discovery a watershed moment. The other prevailing theory was called hierarchical accretion, where objects from different areas of the solar nebula would collide to form an object. Arrokoth is the most distant, most primitive and most pristine object ever explored by spacecraft, so we knew it would have a unique story to tell, Stern said. It's teaching us how planetesimals formed, and we believe the result marks a significant advance in understanding overall planetesimal and planet formation. Thank you for watching. For more videos, subscribe to our channel and hit the notification bell. See you next time.